Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome, or hopefully welcome back to the Reliability Matters podcast. I'm Mike Conrad, and I'm so glad you're with me today. Before we get into this episode, now's a good time to click the subscribe button. If you're listening to this podcast on your favorite podcast app, hit the like and subscribe button to be notified when new episodes are released. If you're watching this on the Reliability Matters YouTube channel, click the subscribe button and bell icon to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of each month. And these episodes have been downloaded more than 35,000 times. That number just blows me away. I thought I was going to start a few years ago with about 10 episodes and then go on to something else. But you guys have asked me to stick with it, and you've given me tons of encouragement and support. And I thank you so much for that. I'm very grateful. So if you're listening to this or watching this podcast, then you clearly have an interest in reliability and perhaps even a stake in reliability. To build a reliable product takes more than just you. Your entire team must be aware of your reliability goals and procedures. This requires a substantial amount of training. How do we make that training effective? How do we make that training engaging, inspiring, and dare I say, even entertaining? My guest today is Ledet Henley. She has worked with the manufacturing game since 1998 as a developer of new simulations and training material. She's traveled worldwide in her capacity as a facilitator and trainer for the manufacturing game and other simulations developed by Ledet Enterprises. Michelle has been instrumental in developing simulations with a focus on reliability, project management, and distribution. She began her career with KPMG Peat Marwick in San Francisco and then worked for a real estate management and development firm in the Washington, D.C. area. Before joining the manufacturing game, Michelle formed her own company, Innovative Interfaces, which provides computer programming services around the United States. She has a bachelor's of business administration degree from the University of Texas, Austin, in accounting and information services. And I'm very pleased to say Michelle is our guest on today's program. So without any further ado, I would love to welcome Ledet Henley to the program. Hi, Michelle.
Hey, Mike.
Thank you so much for being here today. I'm really looking forward to this conversation.
Thank you for the opportunity. I love talking about reliability and specifically the human side of reliability.
Well, you got me at, we'll talk about this a little bit later, but you got me at the beer game. I'm like, okay, if that can actually happen, that's awesome. Sign me up, right? But before we get into the beer game, let's put kind of everything in context. First of all, there's one quote you had on your website which just kind of sold me on this concept, and it's a quote from Confucius, and it says, "I hear and I forget, I see and I remember, I do and I understand." I think that sums up what your company's philosophy is. And so we'll put that at the top, and now let's kind of dig deeper. So how did you get started in the reliability space? That's not an extremely common, which is the reason why this show exists. It's the reason why your company exists, right? There's not a lot of people that just specialize in reliability. You know, there's maybe one at every company, so what drew you to that subject matter?
It was a very non-direct route. As you mentioned, I started my career. I got my degree in accounting and information systems, and I pursued the accounting route for a number of years. And eventually, I ended up back in Texas, my home state, and went out to dinner with my parents and started talking to my father about the work that he was doing at DuPont. He's a PhD chemical engineer, and he worked there for the first 27 years of his career. And so he was talking about the work that they had been doing to improve reliability, but mainly a frustration that they had. They were trying to pull some of the metrics from their computer maintenance management system to kind of prove that the work that they were doing was effective, but it was an old mainframe system. And so they had put in requests to get reports done by the people that programmed the system, but that wasn't likely to happen for months or maybe even years. And so they were basically pulling all this data by hand. And so they would get on the mainframe, they would get the data, they would write it down, they would put it into an Excel spreadsheet and then create the graphs they needed to track the metrics. Well, coincidentally, I had been working on some computer programming work that was a PC-based program that would access a mainframe, pull all the data just by basically simulating typing into the computer and then scraping the screen for all the data, and then could put it into a PC program. So I said, I think I could maybe help you guys. And so I started working with them on a contract basis just to pull that data out. And so as I was doing that, I got very interested. They were getting great results. And, my dad was always kind of an engineer's engineer, super nerdy, super technical, but they clearly were doing something outside of his normal range. And we're really focused on people and engagement and getting buy-in and getting understanding. And I was curious about how they did that. And so they had done it with a board game called the Manufacturing Game that they had created. And so I got into it from that standpoint, that I was absolutely fascinated by the concept of reliability in general, making sure that equipment runs the way we want it to run, when we want it to run, how we want it to run. And specifically, I was interested in the people side of it, that I think the technical side gets a lot of attention and a lot of time, and rightfully so. But the people side often gets ignored. And as I heard recently, I thought it was a great explanation, is the soft stuff is the hard stuff frequently. That getting the technical details right can be challenging, but getting the people side of it right, I think, is a lot more difficult for most organizations.
Yeah, you're exactly right. That's been I own a manufacturing company, and that's been my challenge as well, and our company's challenge in general. People come hopefully trained with the technical stuff. That's what universities do. They don't teach the cultural stuff. And
right.
I think so much of reliability really lands in the cultural world, right? There also is a big difference in perception between reliability and quality. I've asked people about their reliability programs in the past, and the first thing they'll do is go, "Oh yeah, we got a great quality program." And I'm like, that's not what I said. Two different words, right? Quality to me kind of reminds me of ISO standards, right? Which is, say what you're going to do and prove you're doing what you say. It doesn't mean it's going to work. It just means you're doing what you intend to do, and that can be audited. There's no guarantee that if you have an ISO rating, certification, that you're producing good products. You're just producing what you intend to produce. And I think quality kind of falls kind of in that same kind of generic description. And, I can buy 10 quality components and 10 quality parts, which means they're not going to break the way they were designed to be used. And I throw them into an environment where they were not designed to be used. And all of a sudden these quality parts start breaking. There was nothing wrong with them. There was something wrong with the climactic in-use environment, for example. So
yes.
I did a very layman's job at describing the difference between reliability and quality, but maybe pick that up a little bit. And are there more differences there? Is that a common misconception? And how do you go about differentiating reliability from quality?
Yeah, I think you had a great definition. And I think one of the challenges with these definitions is so many of them depend on context and who's talking about it and what they mean by those terms. But the thing that I think you hit on that fits well with my definition of reliability is I look at reliability as basically how well something performs in a variety of real world conditions. And so I think that's, you hit on that a little bit of, you can have these quality components, but if you're using them in a way that they were not designed to be used, or you're using them in conjunction with other parts that they were not intended to work with, you're probably going to have some reliability problems. Right. And so, we look at reliability as an organization's ability to produce the products that they want to produce at the proper product quality on a consistent basis, given their normal sort of working conditions. So, I'm living here in South Texas, I'll exempt the day the hurricane comes through. That doesn't necessarily play into it, but on sort of an average day with normal operating conditions, which have a decent bit of variability, how well is your equipment doing what it is that you bought it to do? That's my very simple, non-technical definition of reliability.
Yeah, that's I agree 100% with that. In our industry, in the electronic assembly industry, there are quite a few reliability challenges right now. I don't know if you own an electric car, but or if you don't, you probably know someone that owns an electric car. And one of their biggest complaints would be the public charging stations. Tesla excluded; they do it differently. But the public charging stations that work on every other model, up to at any given time, up to 30% of them are broken, and in some areas it's a little higher than that, and it's terrible. They have an most people have an app that tells them how many stations are available, how many are actually working. And then there's degree of working. There are some that are supposed to charge very fast, but they're only working slow because something's wrong. And it's a huge issue. And the main reason is there were quality components. Everything was done right if the product was going to be inside a climate-controlled, environmentally controlled, safe environment. The problem is these charging stations are outdoors, like a gas station. They are in severe heat, severe cold, severe moisture. They're attacked by rodents and bugs and all these things, and they weren't built for that. In the electronics industry, we have classes of products, class 1, 2, and 3. Class 3 is if it fails, people die. So military, medical, space, highest class. Class 2 is stuff that is expected to work, but nobody really dies. And that's more like office machinery and things like that, office electronics, servers, things like that. Then there's class 1, which is the lowest end. That's consumer stuff. And the challenge we have in our industry is the charging stations are certainly not class 3 by definition.
Right.
No one dies, they're inconvenienced, but nobody dies if it fails. They're probably built to class 2 standards. However, they need to be built to class 3 standards because A, nobody dies, but B, 30% of them should not be broken at any given time, right? It's a huge cost to the EV industry and the adoption of EVs because it's known that charging is an issue. A, there's not enough charging stations, and B, the ones that are there are broken. So that's a big issue in our industry. And that's just one example of unintended consequences, taking quality parts and putting them in non-quality environments. And the entire industry is just desperately trying to fix that. And it's challenging. Tell me about the manufacturing game. And as a company, what does it do? I mean, obviously, it provides some form of unique training for reliability, but tell me more about the company and its inspiration and its genesis and what you do, what services do you offer your customers?
And so the organization was actually started by my father when he retired from DuPont, and he got a license to take the manufacturing game, the product that he had created externally with, and that was part of his retirement package. And so he was able to offer it to organizations outside of DuPont. And shortly after he did that, I started working with them initially just to help him set up his business. But again, eventually I got very interested in the concepts of reliability and the training that they were doing. And so I started facilitating and doing development work as well. The organization, basically, the primary thing that we do is provide a training course. It's a training course that uses a physical board game that teaches some of the concepts of reliability. And more importantly than teaching, it gives people a chance to experience it. So that gets back to that Confucius quote, I do and I understand. And so it gives people a chance not just to be a spectator in the world of reliability, but to be an active participant. And then we provide some support for organizations that are trying to do that through using not just the training, but follow-up beyond that. But that's really where our focus is getting more people engaged in this reliability effort. It reminds me of the safety efforts back in the probably 70s and 80s. Again, I was pretty aware of it because of my dad's involvement in DuPont. And then the big improvements in safety came when safety was seen not as a department or a job role, but as a piece of everybody's job. And I think reliability really needs to be the same as well, that everyone has an impact on reliability, either positive or negative. And that's true from the CEO of an organization through to the engineers, the mechanics, the operators, the people that control the spare parts. Even we've seen that the janitorial staff that works in a facility can have a huge impact on reliability. And so if all of those people are impacting reliability, they need to be a part of the process, and they need to understand what their role is and how they can impact reliability positively as well as negatively. A lot of times they don't understand that things that they're doing are causing damage to the equipment. That actually makes me think about your EV example. You mentioned all of the physical challenges with being in a non-climate control environment and so on. What you didn't mention are users. And my guess is that there are some good users and some not so good users that probably do damage to the equipment as well.
Sure.
And so that's an important part of it that we see in any industry that I'm working in is how is it that the equipment is actually operated? Do the people who are operating it know what they're doing? And are they doing things that are going to either prolong the life of this equipment or more frequently shorten the life of the equipment?
Is that the board game that we see right up there?
That it is. That's our board game. So it's 4 feet by 5 feet. We have up to six people sitting at a single board, and we'll have multiple boards during a workshop. And you can see it's divided into 3 sections. So we have people who are operating the facility on the yellow side, people who are maintaining the equipment, making sure that it continues to run on the green side. And on the blue side are all the support personnel. So people who provide spare parts, as well as all the people who work with both our vendors and our customers. So any sort of outside influence. And we set the game up where the participants are just trying to make product. They've got customer demand that they have to meet each week, and they've got to keep the equipment running to do that. There are a few sort of rules of the road that are part of the game. But other than that, we're really there to facilitate, not teach. And so we kind of put it out there. If here's the challenge, you've got equipment that's not terribly reliable. You've got customers that want product when they want it. You figure it out. And so they have to work as a team to come up with an approach that they think is appropriate. And they get a chance to kind of try some stuff out. And just like in the real world, you get lots of iterations. So you're not either right or wrong. We operate the game in a week-by-week basis. And so you have a chance to try out a strategy, maybe try it for a couple of weeks. If it doesn't work, you have a chance to adjust it and try something differently. And I think that really helps people to understand what it is that they need to do in the real world as well. It's pretty infrequent that we get things perfectly right the first time.
Sure.
And so learning how to iterate through options as a team and take what works and learn from it, take what didn't work and learn from that as well, and do better the next time and the next time and the next time. I think that's one of the things that people walk away with is this idea of we don't have to get it perfect, but we need to start making progress. We need to do something to improve how we're running our equipment.
Yeah, you mentioned safety. You made a comparison to safety, and you're right. I remember when safety became more of a public awareness thing. It was almost like every company just jumped on the PSA for safety, and I've been in many facilities where there's signs so many days since the last accident, and safety is everyone's job, and yada yada yada. I don't see those same signs or awareness, public awareness, PSA type awareness. X number of days since the last recall or reliability issue. It seems to be expected and not promoted widely anyway. I know you're trying to change that, but that seems to be the culture right now. And do you see a change? Do you see reliability in general becoming higher on the awareness chart? Is it? I know it's not as high as safety, but is it approaching safety?
What I've seen is a big improvement in terms of the sort of official professional approach to reliability. So you see reliability engineers. You didn't have those, or not many of them 20 years ago. And so there's definitely more attention that's on reliability. The downfall I see is that it tends to be very specific. It's management and it's engineers. I don't see a whole lot of effort put into bringing everybody in the organization in on reliability like we saw in safety. So again, this to me, it reminds me of the early days of safety where you had the safety manager, and it was the safety manager's job to make sure the site was safe. And that's better than ignoring safety. But it really, you don't get the improvement until you get everybody involved in it. And I think that's where we are with reliability at this point, is that it now needs a much broader audience, and it needs to involve a lot more people than just the professionals, just the reliability engineers.
Sure. Well, you come with an accounting background, so this is not unfamiliar to you. I think one of the reasons safety made its way to the top is some accountants figured out how much workers' comp goes up when there's safety issues, right? It became an economic decision. I would like to think it's also because employers care about the safety of their team. However, I think what drove safety kind of to the point where it became widely aware and promoted and trained is because it had a cost benefit. Someone did a cost benefit analysis and realized it was cheaper to keep the accidents from happening than to pay off the people who, become amputees, whatever, because they showed up to work. However, reliability, I think reliability has a potentially larger cost, or lack of reliability has a potential larger cost. I've mentioned this several times on the show, so forgive me, audience, for hearing this again, but I was hired as an expert witness for a civil litigation matter between an OEM and a contract manufacturer, and the issue was they built a product that ultimately failed, and they had to recall 50,000 units, and it cost tens of millions of dollars to do it. Huge damage to their reputation. They'll never do that again. I assume now they have a reliability initiative now. They didn't then until the numbers hit the fan. And I think as soon as the numbers hit the fan, people become aware, because now it's it's a business decision more than a philosophical decision. Other than the philosophy of not losing money, there's not a lot of philosophy behind it besides let's not let this happen again. So are you aware, is there an awareness amongst your customers and the industries in general that reliable products save money? They save tangible and intangible amounts of money. Is that out there yet, or is it still, they have to get hit with a big lawsuit or a big loss before they figure that out?
It's interesting because, I think it comes down to this idea of risk and our human perception of risk. And so with reliability, you get the issue, you have maybe a pump that's not performing the way it's supposed to perform. And so at some point it's going to fail. But no one can say with certainty on what date is it going to fail. And so it's this challenge of, do we take it out of service right now while it's still functioning to do some restorative work that we know needs to be done? Or do we try and run it just a little bit longer and a little bit longer and a little bit longer? And the fact that we don't know for sure when it's going to fail makes that very challenging, I think, for people to accept that there's a known loss of revenue if you take it out of service. There's product that you can't produce at that moment. And people wonder, well, is it really going to fail in the next month? Is it really going to fail in the next 6 months? And so there's not a big trust in terms of how certain are we that that's going to happen, and can we just kind of let it ride and hopefully we'll get some extra life out of it and not have to spend this money. And so I think that's a real challenge right now that, ultimately, there's a lot of data that shows that having more reliable equipment is a much safer way to run and a much less expensive way to run. In fact, the work that started at DuPont that led to the game was a worldwide benchmark. And the folks that were doing it kind of had this idea of they were going to prove to the company that the problem was they weren't spending enough money on maintenance. And if they would just spend more money on maintenance, then reliability would be better. And what they ended up finding is that the type of maintenance they were doing, reactive maintenance, so waiting for something to fail and then fixing it as quickly as possible was actually the most expensive type of maintenance you could do. The maintenance costs themselves were 25% higher than the organizations that were proactive, that would take things down before the equipment failed and do the restorative work that was necessary. And that's just looking at maintenance costs. I think the production losses are probably something like 10 times that level of impact. And so I think it's really challenging. And you mentioned safety. I think there definitely was a point where people started doing some of those cost calculations on safety. But again, I go back to DuPont, having grown up in that environment. The reason that DuPont had a focus on safety is because they started out as a company making gunpowder. And that was in, I think, the 1800s. And they would have a lot of accidents. And when they had accidents, things would explode. And when things exploded in the 1800s, typically people died. And a lot of the DuPont family members actually worked in the facilities. And their children went to school. They had kind of company properties, and they would have the schools very close to their production facilities. And so when they would have these safety incidents, a lot of times they would lose family members. And so it was that very personal connection.
They had a stake. They had a stake in reliability now, or safety in that case.
Yes. They had a stake, absolutely. And the fact that it was very personal to them, I think, is what led to that sort of company culture of making sure that, hey, we're going to do this, and we're in business to make money, but we're not going to do it at the expense of hurting people in our organization. Yeah. Or at least we're going to certainly try not to.
Sure.
And, I think with reliability, probably it's going to be the same thing. People need to have that horrible moment where things go terribly wrong with reliability, and they say to themselves, it's just not going to happen here again. And what is it that we can do as an organization to make sure that we're not back in that position someday?
Sure. And in the electronic space, I'm sure you've heard of the term IoT, Internet of Things. Everything is becoming a connected device, from things that are obvious like cell phones and to toothbrushes and doorbells and things like that. I mean, we're putting electronics everywhere. It's an evolution right now as we speak. And so I think that is like DuPont's history with gunpowder and explosives, things like that. I think we're now in an era of awareness because the costs are louder, they're bigger, they're more obvious. With going back to EVs, when GM had to tell buyers of their Bolt not to park their cars in the garage because they might spontaneously combust, true story, not great PR for GM at that moment. That I'm sure they became keenly aware of a quality product in an unintended environment or unexpected environment causing a problem. So I think we're at a time, at least in the electronics industry, when people are now being kind of dragged and kicking into this reliability conversation because now it's more meaningful. You mentioned DuPont several times. Your father worked at DuPont. I cut my teeth with DuPont products. I'm in the cleaning industry within the electronic space, and the first products we worked with were Freon. Freon turned out to be a really great solvent until the government said you can't use it anymore because it was chewing on ozone. But I played a lot, probably more than I should have. I used to wash my hands in Freon, and my hands would turn white, because it took all the oils off. But that was, back in my 20s. So I don't know much about DuPont except they made a great cleaning product that unfortunately went away. Can you share kind of a real life case history? We don't need to know who the players are. You can protect the guilty or the innocent, where you were able to change the perception of reliability. Have you witnessed an aha moment? Maybe they came to you because they were told to. Maybe they came to you because they're like, okay, whatever. This is, sexual harassment training, quality training, safety training, and now we have to add reliability training, right? Maybe they came to you under that pretense. Did you witness any aha moments where people just got it?
It's one of the things that I absolutely love about using the manufacturing game as a training product, because we get that aha moment every single workshop that we run. that it really is, what we're teaching isn't rocket science. It's about finding defects and eliminating them and focusing on the small issues. It's not anything that's technically very new or innovative or exciting, but how the system all works together is very interesting. And I think that's part of what people get from participating in the simulation is this idea of, oh, okay, I understood all the bits and pieces. Now I understand how they fit together and work together. And I understand the leverage points that we have, the areas where we can spend some time focusing and really make some big improvements, even with some very small efforts. But I'll share some specifics. We have one client who's been very vocal about their improvements. And this was one of our first clients that we worked with. It was a refinery. And they had been told that, they weren't performing terribly well and they were going to be sold possibly. And then very quickly they said, we've changed our mind. We're probably not going to sell you. There's too much refining capacity in the United States right now. We think we're just going to shut you down. But we're going to take 2 years to do that. And so these folks were really faced with the crisis of what do we do? And, this is a small town that was very dependent on this particular refinery for jobs and careers for folks and had been, I think it was started by Rockefeller. So it was a 100-year-old refinery. And the idea of this refinery going away was really tough for the people that lived and worked there. And so they made the decision that whether they were going to be sold or shut down, they wanted to handle the last however many years of operation of this particular site that they could. And they wanted to do it kind of their way. And so they got absolutely everybody in the organization involved. They even involved a lot of the local community in their efforts to make improvements and make sure that they were the absolute best they could possibly be for whatever time period they had left. And they made, in just 18 months, made substantial improvements. And in fact, so much improvement that the company that owned them decided rather than shutting them down, they actually were going to sell them. They found a buyer and sold them. They've been sold, I think, once or twice again since then. And it's been interesting to talk to the folks who are still there, where they say, regardless of who our owner is, we now think of ourselves as, this is our refinery, and we're going to make sure that we're running it the right way and that we are reliable and safe. That was a huge thing for them as well. And make sure that, we hope this place is going to be here for another 100 years. And we know that we have at least some control over that, if we can make this a better place to work, a more efficient operation, it's more likely that it will continue to exist. And it was just fantastic to see that even after all of these years, they still kind of had that sense of pride of this is our place and we're going to make sure that it runs the way it's supposed to run, no matter whose logo is on our paychecks.
Right. Different logo on the paychecks, different signatures, but the same people.
Exactly.
And I guess you can say reliability saves jobs. There's another reason, right? Another finger on the scale.
Absolutely.
It seems to me that, at least from a 30,000-foot view, that there are two challenges with reliability. One is to establish benchmarks, and the other is the process in which those benchmarks can be obtained, right? It seems to me also that establishing the benchmarks, while difficult, is probably not as difficult as the route to obtaining those benchmarks. So how do you differentiate between the two, and how do you provide assistance in the journey to obtain reliability? So you got everyone excited. They played the game. They get it. They got the aha moment. And is that it? Do they just go and, go forth and multiply reliability? Or what are the next steps once you've kind of opened their mind?
Yeah, the key for us, and it was something that is a personal pet peeve of mine, certainly plus of my father's as well, is, over the course of our careers, we had been to lots and lots of training, some of it horrible, some of it okay, some of it really good. But most of the time when we would get back to work, it was like, okay, put that aside and let's get back to work. And so it was very frustrating to have new ideas and new understandings and not have an opportunity to put them into practice. So we said, with the manufacturing game, we're not going to do that. We're going to make sure that people have the opportunity to use what they learned and to do that as quickly as possible and as often as possible. So part of what we do with our 2-day workshop is on the second day, during the course of the workshop, during the simulation, they're learning about this idea of defect elimination, finding things that aren't quite right, that you have some control over, and then making improvements so that those defects are no longer impacting the operation. And so on the afternoon of the second day, we have them do that in real life. And so they take on small projects. We divide them into small teams, 6 to 8 people, and each team takes on something that they know of in their area that's not operating properly. And they figure out, what's going wrong with it and how can we fix it, and fix it in a way where we don't have to come back and fix it again. So not just a patch, not just replace a part, but how do we dig into what's really causing this problem and make this problem go away, hopefully forever, or at least for a longer period of time. And so they pick a project, they pick something they can get done in the next 90 days, and then we follow up with the teams to see if they were able to accomplish what they had originally set out to accomplish. And then that is hopefully the first of many projects that these folks are going to do, where they notice defects and they get together a small cross-functional team that goes after it and makes the defects go away, again, in a way that they don't come back and we don't have all those repeat failures. I think it's incredibly important that people have the opportunity to apply knowledge. And I think if you don't give them that opportunity, very quickly that knowledge goes away. And
sure.
I think even worse than sort of not training them in the first place, if you get them excited about something and you don't give them an opportunity to use that knowledge, they're going to be worse for it, because they're going to have gotten their hopes up and then had their hopes dashed. And that's how you create cynics. And we see an awful lot of those at the different sites. People who've been there, done that. They've got the ball cap and the jacket and all of the logos, and they say, yeah, and I'm still doing things exactly the same way I was on the day that I was hired in 1994.
Yeah,
and so
it was a
it's
check
very,
mark.
very important that they get a chance to apply it.
Sure, it's a use it or lose it proposition.
Absolutely.
Like so many things in training. What are the common misconceptions about reliability? What do people, when they come to you, obviously someone's ordered them to go, right? It's like community service or, whatever, jail. They're told to go, good for the company for at least, starting that. But do they come to you with like a common misconception about reliability that you kind of have to reprogram?
I would say the majority of the folks, they walk in the room and first of all, they're seeing a board game and they're like, I think I'm in the wrong room. But a big part of it is they don't see reliability as being part of their job. So again, we'll have some engineers in the room, but we have a lot of operators and mechanics and support folks who say, yeah, reliability. I hope those guys are doing a good job with it. And so I would say the biggest misconception is that they just don't realize that it's part of everybody's job. Everybody in the organization, again, from CEO to janitor, has a role to play in improving reliability. Another thing I think that a lot of them come in with a misconception on is that it's all about the technology. And it's about, coming up with better designs and using the latest and greatest. And we have old equipment. Old equipment can't be reliable. And none of those things are really true. Technology can be used to improve reliability, but it doesn't necessarily have to be. And a lot of times it's just getting back to the basics and getting the basics right. That's a huge part of improving reliability. And I would say the final thing that I see pretty frequently is that people think that improving reliability has to be a handful of very large projects. We're going to implement reliability-centered maintenance. We're going to have a root cause failure program where we look at every failure and do a root cause analysis. And there certainly can be some big projects that help improve reliability, but a lot of it is just hundreds and thousands of small projects. And the impact of those, making those small stops, those small defects go away, can have a huge impact on the reliability performance, every bit as much as the one or two large projects that happen every year.
And your company provides training. Well, I shouldn't say that as a statement. I should say it as a question. Does your company provide training to various industries? You mentioned oil and gas as one example. Your father was with DuPont. So when he was with DuPont, the training was DuPont-centric, right, on covering processes unique to them. Now that they gave him silver cufflinks and a license to sell the game, I'm sure expanded the customer base. Do you work with a number of different industries?
Yeah, we do. And that was one of the concerns I think that we had initially is we said, okay, we know it's going to work in a chemical plant because we've seen it. A refinery is a very specific type of chemical plant, so we know it's going to work there. We really weren't sure going beyond that. But since then, we've worked with pharmaceutical companies, consumer products, diapers, and things like that.
A lot could go wrong with diapers.
Amazing. It was one of my favorite places to work because just to see all that goes into it and the fact that they have to change the design of a diaper every 12 to 18 months in order from a marketing perspective.
Yeah.
And they have secret parts of the process that only a handful of people are allowed to see because that's the special thing about the diaper that particular day.
It's their version of the formula for Coca-Cola, right?
Exactly. But it was fascinating going from a place where, it's hard hats and steel toes and maybe breathing air to, okay, you got to wear a hairnet and the factory smells like baby powder.
Wow.
Very different. But, we got into the details are different in terms of what they need to do to improve reliability, but the overarching concepts are absolutely identical.
That's exactly where I was going with it. That's a perfect segue because to me, reliability is a concept. It's a culture. And
yes.
It can be tuned, but you're not. If someone from our industry came to your company and said, "Okay, help us with reliability," you're not going to tell them, for example, I'm going to get geeky on you. Make sure you clean your boards to avoid electrochemical migration, dendritic growth, and parasitic leakage. That is way too far down the rabbit hole, right? I think reliability is a 30,000 foot view. It's a press box view, right? And it will manifest, the training will manifest itself from an implementation standpoint, very specific to the industry. But I think the concepts are what people need to understand. And then they can figure out how those concepts can be implemented. Is that a correct analysis of
Absolutely.
what you do?
And I think it's important to make that translation, right? So starting at that 30,000 foot view, I think there needs to be an understanding of what is reliability, what are defects, how do we eliminate them? But it needs to translate all the way down to, okay, so now what do I personally do about it? And so we're able to provide that sort of generic 30,000 foot view. And then the environment is just perfect for the people who work at that particular site to get down into the details. So I don't need to understand the details. I just need to set the stage for the conversation. They're going to provide the details that ultimately are how it gets implemented. And I think that you can make a mistake either direction. You can get so bogged down in the details that you've never bothered to rise above and see the overarching concepts. But you also, and I've seen this a lot, is you can get so into the high level and, what are the definitions and how do we see this? But if you never get down to implementation, who cares, right? You may be 100% right, but if you're not getting it done, it doesn't matter. And I think that's where we've had a lot of success, is kind of doing that translation from here are the concepts all the way down to here's what each individual in the organization needs to be doing in order to make a difference.
You can ready, aim forever, but ultimately you have to fire, right?
You've got to fire.
Right.
Exactly.
Where does reliability generally break down? Is it with people, processes, technology, all of the above, others? What's your experience with that?
Definitely all of the above. Depends on what organization you're talking about. But I would say that the one that I see consistently in every industry, every organization is on the people side. And again, it's as much just not getting people involved, not getting people to understand their role in improving reliability that I think we struggle the most with. And particularly in engineering heavy industries, that having been raised by a PhD chemical engineer, he definitely was good on the technical side, soft skill side, not so much. And I think it's something that maybe we're not comfortable with, particularly again in engineering heavy industries, we want there to be a technical solution to every problem. And sometimes there's not. Sometimes it's a people issue. It's a soft-sided issue. And I think that needs a lot more attention, not necessarily because it's more important, but because it's been ignored for a longer period of time.
Yeah, I think people are very siloed in general. Industries are filled with team members who are very siloed. Maslow said, if all you have is a hammer, you see the world as a nail. You see everything as a nail. And if you're a chemical engineer, you see every solution to a problem, a chemical engineering solution, or an electrical engineering solution, or a personnel solution. It really, it's wider than that, right?
Exactly.
How do you get past, you mentioned this as kind of a common response. How do you get past the it's not my job mentality? How do you convince the janitor, the logistics manager, the accountant, and all the people who actually put the product together and ship it out the door? How do you convince everyone that reliability is their job as much as it is the person who designs the product and builds it?
Yeah, I think it's a couple of things. One is people need to understand that sort of what's the current phrase, what's in it for me with them.
Right.
People need to understand that the impact it's going to have on them personally. And it's got to go beyond numbers. So, a lot of times we'll have somebody from management talk to the group and they'll say, oh, if we make these improvements, it'll make this much more money for the shareholders. And you can just see people's eyes glaze over.
Show me the money, right.
Unless they're big shareholders, right? It's like, whatever, And so we always talk about, make sure you translate it into something that's going to matter to them. One of the clients that I work with at a pharmaceutical company, I think, has a great way of saying, he says, it's about having a better day at work. So he said, is it going to save the company money? Sure. But it's going to make, whatever it is that aggravates you. When you come into work and you have a terrible day, it's usually because the defects took over. And rather than doing what you wanted to be doing or thought you should be doing, you were chasing down today's fires. And nobody really likes to work that way. And so I think having that, figuring out how is this going to impact the people who have to do the work, who have to make the changes? How is it going to make their work life better, or maybe even their home life better if they're not always being called out in the middle of the night? So I think that's important. Is you've got to answer the question, why should I care? And then beyond that, you have to answer the question of, okay, what do you want me to do about it? Then I care now. And so what is it that I need to specifically do differently in my job that can make a difference to this bigger picture? And then the final thing is you have to be very clear about how you're going to support them in doing that. Because if you kind of go in and say, look, reliability is important. Here's why. Here's what I want you to do. And then say, I'm out of here. Good luck. Chances are you're not going to get very good response to that. So making sure that they understand how you're going to support them, what you're going to provide, whether it's financial support or just the backing and verbal support. What is it that you're going to do that's going to help them to work in these new ways? Because change is difficult. And if we're not going to support people through change, it's very unlikely that they're going to pursue it on their own.
Yeah, change is scary.
It is.
But so is losing your job because the company's going out of business.
Very scary.
Hence your gas company example, a refinery example. That was the ultimate example of show me the money. The money kept coming because otherwise they would have been laid off and they would have had to turn off the lights and go on unemployment or find another job.
Well, and that's a great point because that's I think how they made the translation. It wasn't about let's make more money for the corporation. And people say, yeah, the corporation that's going to sell us or shut us down, why would I do that? They said, look, forget them. Let's see if we can save this site and keep it running and save our jobs, and whoever owns us. Let's not worry about that.
They saved their town.
That kind
really.
of translation, what was it for the people who were going to be making the improvement? Why should they care about it?
Yeah, that's a great story. As we wrap up, in addition to the services you provide, what general advice would you give? What other resources are out there that you would recommend people, besides hiring your company, to implement a reliability program? What are some helpful resources that are available?
So I'll start with a shameless promotion.
Yes.
In addition to our services, we also have a book called Don't Just Fix It, Improve It that's available on Amazon. And it's actually written in story form. So true to our nature, it's not technical, but it talks about the journey that one particular site goes through from realizing that they have an issue to getting everybody involved in eliminating defects and ultimately having a much more effective organization. And it goes through kind of all the trials and tribulations and all of the challenges, all of the people side of reliability. Very, very easy, quick read. And I think it'll give people kind of an understanding of what the journey is going to be like, not the technical details, but the journey itself. And it's based on some of the experiences that my father had at DuPont, as well as some of the experiences of the clients that we've worked with since then. So that's my shameless plug. In addition to that, there are a couple of really good resources, I think, a couple of organizations that are doing some great work with reliability. One of them is the Society for Maintenance and Reliability Professionals, known as SMRP. They have a national chapter or I guess global organization, but they also have some local chapters throughout the United States and possibly outside of the U.S. I'm not familiar with that. But they have publications, they have forums where they have good discussions on reliability. They also have an annual conference every year. And so they bring together practitioners as well as people like myself who are in the support roles that provide either training or technology. And it's a fantastic conference, a great way to kind of see different views on reliability, different takes. And I've been attending for 20-something years, and every year there's something that I get from it that I say, oh, I hadn't thought about it that way, or that's a new technology I didn't know existed. So it's a fantastic organization. Another organization that I think is really good is the University of Tennessee in Knoxville. They have the Reliability and Maintenance Center. So they have a degree program in reliability. They also have a corporate program where you can get a certification. They also have an annual conference where they get people together to kind of share their stories and experiences, as well as, again, people like myself who talk about the services that are available for people who are trying to make improvements. I will make one additional sort of weird out-of-the-box recommendation. There is a book that I have no connection to called The Storytelling Code by Dana Norris, available on Amazon as well. And I've spoken on this at a couple of conferences recently, but I think the ability to tell an effective story might be the most important reliability tool that we never knew that we needed. Because reliability isn't just about the technical details. It's about getting other people to go along with what you're trying to do. That includes your peers. It includes the management and leadership that's going to be funding any effort. And it includes the people who are touching the equipment, who really either make or break a reliability effort. And again, I think coming from so many engineering-centric organizations and industries, we're not great storytellers, or not at work. A lot of us are good storytellers at home and in our personal life, but we think that shouldn't be part of our job. And if you want to get other people to join your effort, you really need to get good at telling them the story and getting them to care about the effort as much as you care about it and inspiring them to action. So that's my sort of weird out-of-the-box recommendation, definitely non-technical, focused on the people side of reliability.
Which I think that's where it starts, right there. As we said at the beginning of the show, it starts with people. Well, Michelle, you've been a wealth of information. I find this whole entire topic of reliability, hence the name of the show, fascinating. And you bring a very unique perspective to enlightening people and informing people about the importance of reliability and a very non-traditional way to teach reliability. I am aware of the three basic learning methods, and psychologists will tell you there's auditory, visual, kinesthetic. I'm more of the kinesthetic side. Each side has a pro and a con. I was reading earlier, preparing for the show, I was reading the pros and cons of each of those. And on the kinesthetic side, which is me, one of the cons was if there's a break in the action, people get very bored because they're just waiting to be, stimulated. And I think that board game, it reminds me of when I was a kid playing Monopoly with the family. I was ruthless. No one would ever trade with me because they were convinced I had a scheme. It was more than what it was obvious. But I think that whole way of learning it just gets in through a different part of your brain, and a part of your brain that is not used to being trained that way. We're so used to reading, and we're so used to viewing, and we're not used to doing in terms of training. We read, we view, and then we do. It's nice to do before we do, if that makes sense.
Exactly.
So I kudos to that philosophy. Is your dad still with the business?
No, he sold the business in 2014. So my husband and I purchased it from him. He's now actually retired after having a 27-year career at DuPont and a 25-year career post-DuPont. He's getting to actually enjoy his retirement for a change.
Very good. Very good. Well, all the best to you. Good luck in the future. It sounds like you don't need it. I think you're on the right path. And thank you so much for spending the last hour or so with me. I really appreciate it. I know my audience will as well. Audience, if you're interested in getting more information on the manufacturing game, I'm going to have Michelle's contact information in the show notes. If you're listening to this on your favorite podcast app, as soon as you're off the treadmill or you get to your destination, scroll down and look at the show notes, and Michelle's information will be there. Also, Michelle mentioned a book. Michelle, remind me again the name of the book that you guys produce?
It's called Don't Just Fix It, Improve It.
Don't Just Fix It, Improve It. It's available on Amazon. But, however, if you are the first person to ask for a copy of the book, send me an email. My email address is in the show notes, mike@mikeconrad.com, Conrad with a K. Send me an email. Be the first person within the U.S., just because of mailing logistics. We will, Michelle has graciously volunteered to sign the book and send it to you free of charge. The rest of you, unlucky people who weren't fast enough, then you can order that book on Amazon, as you can the other book that Michelle recommended, and I will provide the links for that in the show notes. If you're watching this on YouTube, click the Show More button right down here, and that will also display Michelle's contact information and the book information referenced in our conversation. So Michelle, thank you so much for being my guest today. I thoroughly enjoyed our conversation.
Yeah, I did too. Thank you for the opportunity, Mike. And if anybody has any questions, you mentioned my contact information. They're welcome to email me directly. I'm also pretty active on LinkedIn. So if anybody's interested, connect with me on LinkedIn. Happy to discuss reliability, defect elimination, the human side of reliability, any of those topics.
Excellent. And I will have Michelle's LinkedIn information available also in the show notes. So again, thank you, Michelle.
Yeah, thank you.
Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. As I said earlier, our podcasts have been downloaded more than 35,000 times, and I remain ever grateful for your support and encouragement. Don't miss an episode. Listen and subscribe to the Reliability Matters podcast on your favorite podcast app, or watch it on the Reliability Matters YouTube channel. If you're watching this on YouTube, now's a good time. If you haven't done it already, click the subscribe button and the bell icon to be notified when new episodes are released. We do release new episodes on the second and fourth Tuesday of every month. And a special thank you goes out to Circuit Assembly Magazine's PCB Chat at PCBchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks for your questions and episode suggestions. Please keep them coming. You can send them right over here to my email address for those that are listening to the podcast. That's mike@mikeconrad.com. That's Conrad with a K. Once again, thanks for listening or watching. Until next time, stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.